Hello and welcome to Recyclist. I'm your host, Eric Provost, and this is part 2 of my discussion with Econward's Joe Ayala. We are learning all about their groundbreaking BIOMAK system, so let's go ahead and jump right back in to the conversation. Using the biomass as feedstock for anaerobic digestion kind of speaks for itself. You've touched on a little bit about the potential use of the byproducts from the inorganics. Just kind of very quickly for those people who may want to incorporate this system, what could they potentially use on the back end, the inorganic byproducts? Where could they, put those or sell those or get rid of those?
Look, the plastics alone. So in waste, we found in municipal solid waste, people are landfilling 10 to 20% plastics. Those plastics, if they are properly separated and because they are cleaned by the steam, um, they become extremely valuable. A ton of PET can be sold between $300 and $1,000. A ton of aluminum is worth over, $1,000 is extremely valuable. Metals are really, really valuable. And so having a clean non-organic fraction becomes very valuable, and that will enable authorities that are nowadays spending a lot of money in transport and disposal. It will give them another option, right? To be able to capture materials that otherwise are commingled in the MSW that are inaccessible, right?
So is that the entire thought process behind using this unique type of system was, hey, we can completely degrade the biomass while cleaning all the inorganics? Was
Yeah,
that kind of dual that dichotomy, was that the intent behind creating the biomax system?
exactly. And the beauty of it is that this is done selectively by hot water molecules, by the steam. So when the steam enters the system, obviously touches, imagine a molecule of steam touching glass, it will
Hmm.
just clean it. It wouldn't do anything to glass or plastic. Plastics are not degraded by steam at low pressure, but the organics will be hydrolyzed, will break into smaller chains. So yeah, that's exactly the objective. And um, this is achieved by thermal hydrolysis. This is what steam does to garbage. um, but one of the reasons why this is now becoming more and more accepted is that we are seeing, or we are experiencing, the limits of mechanical separation. Think of what we do as humans to garbage today, right? So even for the implementation of SB 1383 here in California, we are trying to divert organics. Those organics are from MSW. They are commingled with non-organics, and the current mechanical systems. You have shredding, extrusion, milling, dilution, etc. All of those mechanical methods, and what we are seeing is the limits of those mechanical systems. We are achieving their physical limits, and we are not achieving the diversion goals that we have, right? So this is why this technology, why the use of steam is becoming more and more relevant, for the separation of these fractions.
So using the system right now, you talk about reaching the limits of mechanical separation. Um, what limits do you think, like, are we approaching, I don't know if it even makes sense to put it in this regards, but like 100% separation of organics versus inorganics, 100% breakdown of organic matter, 100% clean inorganic waste. I don't even know, like I said, if it makes sense to quantify it that way. But you talk about the separation process mechanically already reaching its limits. What can we expect from the thermal hydrolysis to go beyond that?
Yeah, the beauty of thermal hydrolysis is that steam it's very selective. Steam will hydrolyze organics but won't do anything to the non-organics. So effectively, you have the opportunity to hydrolyze all of your organics and to clean all of your non-organics. So, in that sense, steam will reach. Obviously there are questions of volume and etc. etc. But and time and residence time, but yeah, we achieve a 96 percent organics capture in our systems on a standard working day. But it's not because but it's simply because we are using steam instead of mechanical methods, right?
Yeah. And in terms of implementing the BIOMAK process, where are you guys in terms of commercial application?
We have a plant operating in Spain, in Madrid.
Hmm.
And part of the reason why I travel often to Madrid is to show clients this this system, which has a 65,000 tons per year capacity, and is fully automated, fully autonomous. And what we
You
do
kind
in
of
Madrid,
glossed over that, but I
yeah,
want to 65,000 tons per year.
yeah. In terms of solid waste, that's a drop in the ocean. Eh? It's a good capacity, but imagine in LA, for example, where we are located, uh, there are facilities that process over 1 million tons a year, right?
Well, I mean that's the
Yeah,
that's the whole point of expanding the process. One plant may be able to do 65,000, two plants can do 130, three plants
exactly.
can do 195, so on and so forth.
Exactly. So yeah, we have a facility working in Spain that is taking MSW, separating the organics. The organics go to a anaerobic digestion process located inside a wastewater treatment plant, which, by the way, there is a lot of spare capacity in AD, anaerobic digestion capacity, at wastewater treatment plants. And the non-organic fraction goes to a further recycling, where they capture all the aluminum and the plastics and the metals.
So, in terms of actually implementing this, in terms of creating new plants, what's the process of, say, um, my landfill is really interested in this process. My wastewater treatment plant is really interested in this process. Do you create a place on site, or do you have a facility that they'll bring the waste to, or how would it
Mm.
actually work for
Well,
clients?
yeah, that's an excellent question, Eric. Thank you. The What we try to do always is to use existing infrastructure. So usually waste management authorities, they have already a solid waste infrastructure. They have transfer stations or MERF, material recycling facilities, in place. So what we will do is to install a biomac at the back of one of them, without modifying too much the existing infrastructure, and then we will send the organic fraction to an existing AV, be it the wastewater treatment plant, or for co-digestion at a commercial anaerobic digestion plant. But the objective is always to use first existing infrastructure, because that makes the project more economically viable, right?
Yeah. So, what would how long do you think the turnaround would be if you say, "Hey, I really want to implement this"? How long do you think, if somebody was willing to sign on the line right now, how quickly do you think they could start to integrate this process into their day to day operations?
Maybe 12 months, a
Oh,
year.
really? Okay.
So yeah, yeah, it takes a few months to nearly to build each one of these machines, between 9 and 10 months, and plus the deployment. So it will be a year, but it will take you a year to do also the civil and all the permitting that you need to to install a machine on the back of a MRF or a transfer station. Yeah.
Yeah. And obviously you guys are looking outside of California to implement these. Have there been any challenges when it comes to legislation across the country, especially with the new administration that just came in? Have you guys ran into any roadblocks when it comes to, getting all getting all the signatures you need and getting all the red tape out of the way?
Look, we are doing a lot of work in the northeast of the
Hmm.
country, and eh, I think in a way, um, people are more conscious, more aware of their cost. So with all of these changes, right? Like there are less incentives now for renewable energy and whatnot, but making the right thing and doing the right thing, so we are gaining a lot of traction in the northeast, where we are seeing county level authorities, waste authorities, pursuing RFIs and RFPs uh, to improve their current organic diversion, because they know that no matter who is in charge at the federal level, they still have to do the right thing at a county level, right? So I will say that waste management is a recession proof, initiative, because like now, for instance, is being penalized from different, but it's still growing, because the need to do better with in terms of waste management is such that affects local communities, right, and affects their pockets, right? Um, so that's very encouraging.
Yeah. I feel like we're going to continue to see more bills. We're going to continue to see more legislation like California when it comes to, because the entire reason we were talking about that state bill was the fact that they were requiring a certain percentage of the solid waste to be sorted, or to have to go through some type of process that you guys manufacture, that you guys service. And I do think that ultimately we are going to continue to march down that path. So I think that, especially when it comes to compliance, there's a lot of technology, especially in the waste industry, that's come about just to help, companies,
Yeah,
landfills, wastewater treatment plants, and stuff
yeah,
like that, help them with governmental compliance. So I think that continuing down this road, ultimately, most states are going to wind up adopting some type of
yeah.
state bill like that. And eventually, a lot of the waste industry is going to have to kind of come on board with some type of of, sortment process like the BIOMAK.
I agree. Look, philosophically, if you try to look at the fundamentals of what is happening and what we are doing today, um, when we take garbage, that, by the way, we produce, as humans, we waste a lot, right? So I guess in the future, our kids and our grandkids, I think they will be more aware of that. But the fact that we have created landfills, because that was the best idea that we had, right? And today the biogas industry has developed landfill gas collection systems that are very effective, but fundamentally, landfilling materials that are valuable is not the smartest thing to do. It was probably the smartest thing to do up until now, but there is a shift. People will waste less, and people will try to find beneficial uses for their waste, not only the organics but the non-organics. And I think my kids and your kids and our grandkids and next generations, they look at landfilling as something that humanity did because there was a need, and that was where the technology was at the time. But there will be this one and many other technologies, robotics and artificial intelligence and you know who knows, that are going to help uh, to 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 address, and improve our waste management um situation.
And if anybody's interested in checking out the BIOMAK process for themselves, learning more about yourself and Econward, where can they do that, Joe?
Well, the website is the best place. It's econward.com, and contact us. All our contact details are there. My name is Joe Ayala. I'm available.
All right, wonderful. Thank you so much for joining us again today. Super interesting. The whole thermal hydrolysis aspect of it really, really interested me. It's such a unique, novel, and interesting way to approach the waste industry going deeper into the 21st century. So I really hope that everybody goes and checks that out. Again, that's econward.com. I'll make sure to link that website in the description of this episode so everybody can go see it for themselves. Once again, Mr. Ayala, thank you so much for joining us today.
Thank you, Eric. It has been a pleasure talking to you today.
Awesome. And after you go ahead and check out Econward and everything that they're doing with the BIOMAK system, if you would do me a personal favor and check out diamondsci.com. That's diamondsci.com. They help make Recyclist possible. You can also give them a call at 321-223-7500 to set up a personalized presentation to see all the solutions they can offer to you. I want to thank you all for tuning in to this week's episode of Recyclist. My name is Eric Provost, and we will see you guys next time. Thank you.